Hi everyone, and welcome to the first of two videos going through some past paper questions on the topic of covalent bonding. And the first question we've got is just what is meant by a covalent bond. And this is a very specific thing they're going to want you to say. A covalent bond is a shared pair of electrons. And that's actually all we need to say to get the mark, but obviously the word pair is important here. Then it wants us to do a dot and cross diagram to show the bonding in boron tribromide. Okay, so if we have a look on our periodic table, boron is here in group 3, and it's going to be bonding to, it's tribromide, so it's going to be bonding to 3 bromines. So we're going to have boron in the middle, and it's going to bond to 3 bromine atoms. Bromine is from group 7, so it's got 7 electrons in its outer shell. So it's just going to share 1 electron. These are just going to be ordinary covalent bonds. We only ever need to draw the outer shells when we're doing dot and cross diagrams. We'd be here all day drawing bromine's electrons otherwise. Right, and then boron, we said that boron is in group 3, so it's only going to have the 3 electrons in its outer shell. So that's it, we're done. This is an unusual example that comes up at A-level that you wouldn't have seen at GCSE, where it actually doesn't have 8 electrons in its outer shell. Okay, boron only has these 3 electrons. That's all it can do. There are no other electrons to put on there, but it is actually stable despite not having 8 electrons in the outer shell. We then have another example here of another dot and cross diagram. So it wants us to draw a molecule of F2O, okay, and it actually tells us here the oxygen atom is covalently bonded to each fluorine. So they're giving us a bit of a clue here. So we're going to have our oxygen in the middle, bonding to the 2 fluorines. Again, if you have a look on our periodic table, again, fluorine is in group 7, so it's got 7 in its outer shell. It just wants 1 more electron, so it's just going to make a standard covalent bond with the oxygen. And the same here. And then oxygen is in group 6. It's going to have 6 electrons in its outer shell. So we've already done 2, 3, 4, 5, 6. And so as our oxygen, it's got 2 lone pairs of electrons. Carrying on, let's have a look what else we've got to do. So now we want to draw a dot and cross diagram for a nitrogen molecule. So nitrogen is just N2. And again, look, it's telling us to only show the outer electrons. Even if it doesn't say that, you always only draw the outer shell. Nitrogen is in group 5, so it's going to have 5 electrons in its outer shell. So therefore, it needs 3 more electrons to get up to having 8 in the outer shell. Okay, we've already seen with the boron tribromide example that molecules don't have to have 8 in the outer shell for them to be stable, but it is the most likely electron configuration for them to be stable. If we can draw a dot and cross diagram where the elements do have 8 electrons in their outer shell, that's going to be correct most of the time. Okay. So if we've got 5 in the outer shell, we want 3 more. So these nitrogens are going to have to share 3 electrons each. Okay, and we're going to have a triple bond. They would have had 5 in the outer shell, so 3 dots means I need to draw 2 more. And then 2 crosses here, and then just do a check. There's 6 electrons there, 7 and 8. So that nitrogen's got 8 electrons. This nitrogen also has 8 electrons. So they've both got a full outer shell. Finally, in this one, we've got this molecule here. It's saying one of the bonds is a dative covalent bond. What is a dative covalent bond? So they've already told us here that a covalent bond is a shared pair of electrons. So we don't need to rewrite that again. If that sentence wasn't there, I would start by saying it's a shared pair of electrons, but they've already said that. So it's a shared pair of electrons where both electrons in the bond have been donated by the same atom. So instead of being a normal covalent bond, which if you were drawing on a dot and cross diagram, you'd draw it as a dot and a cross, a dative covalent bond is going to be 2 dots or 2 crosses. They're both, it's still a shared pair of electrons, but both those electrons are being shared from the same atom. So now it wants to draw a dot and cross diagram for this molecule, and show where the dative covalent bond is. Okay, so we've already got the structure of the molecule here, so we can see what it's going to look like. Okay, so we're just going to copy out this structure with the circles like we've got here. So we've got our N and 3 hydrogens. That's bonding to a boron with 3 fluorines. And the easiest way to do this molecule then is to just compare it to things you've already seen. So we've already done boron tribromide earlier on in this video. So this boron with the 3 fluorines bonded to it is going to be exactly the same as that. Okay, it's going to be just 3 covalent bonds and then the extra electrons on the outer shell of the fluorine. And then this part of the molecule is going to be very similar to, well, it's ammonia, isn't it? It's NH3. NH3 has 3 single bonds, and then the nitrogen has a lone pair. Okay, because remember, nitrogen, it has 5 electrons in its outer shell, so it's going to have 3 in those bonds and then a lone pair here. We do need to be very careful here though, before we just start going and putting dots and crosses in, because we need to make sure that we're using the right symbols. Okay, what we've done already is we've used crosses for the fluorines, so therefore the boron is represented by dots here, so therefore the nitrogen is going to have to be represented with crosses. So this is going to have to be crosses here, and then these bonds are just a dot and a cross, and we can say the hydrogens are the dots. That's fine. But it is very important that we have crosses there. If I'd done this the other way around and put 2 dots there, that would be wrong, because it would then look like they're the electrons from the boron. These electrons are from the nitrogen. This is our dative covalent bond, look, because we've got 2 electrons both being shared by the same atom. It does say that we should label the dative covalent bond, so let's do that. Okay, it's the nitrogen that would have had a lone pair if it was part of ammonia, but it's then donated both those electrons to make a bond to the boron.